Hi guys, today we're dealing with exam revision numerics. So I took these questions from the past papers of numerics. So in this video I'm going to treat all of them. If you feel that there are questions that are missing here and then you have them, you can just leave a comment on the video and then I will make another video updating the new questions that you have. So let's look at this one. This is a question 3. I don't know which year. I just took them from the past papers. Those papers doesn't have a date. So let's look at your question 3. Question 3 was like this one. It's a Jacobi and then Gaussian method. So it says that consider the system ax1 plus bx2 is equals to e. cx1 plus dx2 is equals to f. Perform 2 iterations of the Jacob method for the system above, taking the x initial is 0 and 0. Tabulate your results. So what you have to know here, you have to know the algorithm of the Jacobi and then the algorithm of the Gaussian. So the algorithm of Jacobi is going to be like this. Since we have 2 equations, so for equation 1 we're going to have something like this. We're going to have x1 of 1 is equals to 1 over a 1 open bracket b1 minus a of 1 to x2 initial. So remember, the reason I'm putting 0 here as an exponent, that means I'm referring to the x2 initial, the given one as an initial, this x2 here, because this x initial is 0 and 0. That means x1 is 0 and then also x2 is 0. Then for the x2 algorithm is going to be 1 over a 2 open bracket b2 minus a of 2 1 x of 1 initial. So here in a Jacobi method, you are substituting with the initial values that you are given. You are going to see the difference when you go to the Gaussian. So to do this, now we have to rearrange this equation. So according to the algorithm, that means for the first equation we have to make x1 as the subject of the formula. For the second equation we have to make x2 as subject of the formula. So we are going to have something like this. Let's rearrange the equation 1 now. It's going to be x1 is equals to e minus bx2 all divided by a when you rearrange it. And then for the x2 it's going to be f minus dx2 divided by nope, it's not like that. It's not d, it's c x1 divided by cx1 divided by d. So it's like this. x2 is equals to f minus cx1 divided by d. So this is the rearrangement of these 2 equations. So since we are told that we have to tabulate our results, so if you tabulate this, it's going to be like this. Let's change the color, and then we are going to have something like this. So this is a table, and then here just write m, then write 0, or they told us to do 2 iterations, then 1, and then the last one is 2. Then do this, increase the table. So there's going to be x1 here, and then this is x2. So that means here we're going to put the results of x1 as m is equals to 0. So since we are given that for x1 when m is equals to 0, x1 is also equals to 0, we are given that. And then we are also given that for x2 when m is equals to 0 is also equals to 0 as the initial values that you are given. Then we are going to substitute here 0 and then the 0. So we are substituting 0 and 0 because we are given as the initial values. Then we move on to the first iteration. So for the first iteration, we just come to this equation here and then substitute x2 initial, x2 0. So you have to substitute x2 0. So if you substitute by 0 here, so that means b minus multiplied by 0 is going to be 0, and then you are going to left with e over a. You are going to left with this is going to be 0. So if you are left with that, so therefore the x1 for the first iteration is going to be e over a. That's the first iteration of x1. And then for the x2, we are going to substitute here. We are going to substitute our x1 here by 0. And then if you substitute by 0, therefore c multiplied by 0 is equal to 0, and then you are going to left with f over d. Then if you are left with f over d, so that means your first iteration of x2 is going to be f over d. Then we move on to the second iteration. So now for the second iteration, we're going to have x1 is equals to e minus b x2. We substitute by the first iteration now. We're no longer substituting by the initial one, because always we substitute by the previous one. So now, because we have the new values here, we're going to use them to substitute here so that we can get our new x1. So how to do that? You just substitute x2 by e over a. So if you substitute x2 by e over a, you are going to have something like this: x1 is equals to e minus b open bracket x2 is f over d. Remember that this is the x2 of 1 of if m is equals to 1. So you are going to get f over d from there, what you calculated the previous, and then all of this divided by a. Then this is your final, this is your answer. And then if you write it here, it's going to be e minus bf over a, all of it divided by a. That's it's our answer for the second iteration for x1. And then we're moving on now to x2. So when you calculate the answer for x2, x2 is equals to f minus c open bracket. I have x1. X1 is this. I'm still using the previous one, so it's going to be e over a. And then if it's like that, you divide it by it was d. You divide it by d. Then if you divide by d, and then x2 is equal. So your x2 is going to be f minus ce divided by a all over d. That's your x2. So your answer is going to be f minus ce over a all divided by d. That's your x2. So that means you are done. You calculated x1 for the first iteration and then x1 for the second iteration, and then they ask you actually to do 2 iterations. Then we're done. So let's move on to the second equation. Then the next question says, perform 1 iteration of the Gaussian method for the system above, taking the x initial as 0 and 0. Tabulate your results. So our algorithm is going to change a bit. Now we're going to have something like this. For x1 is equals to a over x1 is equals to 1 over a11 open bracket b1 minus the a of 1 to x2 to the power 0, which is the initial x. So for the x2 is equals to 1 over a22 open bracket b2 minus a21 x1 of 1. So x1 of 1 is this one. is this the previous one here, so that's a x1 of 1. So is this one. That's why the Gauss-Seidel is not the same as the Jacobi method. So when we calculate, we're going to do what we did previously. First, we're going to draw a table. So for this time, we're asked to do only one iteration. So we're going to have something like this. This is m, this is x1, and then I extend my table here. This is x2, and then this is 0, and then this here is 1, and then 0 is 0 is 0, because we are given here the initial that you have to take as 0 and 0. Then we're going to make x1 the subject of the formula, and then x2 the subject of the formula, as we did previous. So for x1 it's equals to e minus bx x2 minus bx2 all divided by a. And then when we calculate x1 is going to be, since x2 here, according to our algorithm here, x2 we substitute the previous value, the initial one. So if we substitute the previous value, the initial one here, b multiplied by 0, we are going to get 0, and then our answer for x1 is going to be e over a, which is the same as the previous one, e over a. And then we're moving on now to x2. So x2 is equals to, you make it subject of the formula from the equation is going to be f minus cx1 all divided by d. And then x2 is equals to f minus x1, you substitute by the previous x1, because this, according to our algorithm here, it says that you substitute with a recent x. So the recent x is e over a. So if you substitute by e over a, is going to be e over a all divided by d. So that's our answer, f minus ce over a all divided by d. So that's your answer. Then now we're moving on to the last question. So the last question is SOR method. SOR method. So for the SOR method, the algorithm is still the same. It's just you multiply by W. So if you multiply by W, since we are given that we should take our initial values as 0 and 0 and 0. Then for x1, the iteration is not going to be changed, as x1 is equals to W divided by a11 open bracket b1 minus a12 x2 of 0. And then for x2 is equals to W over a22 open bracket b2 minus a of 1 of 2 1 multiplied by x1 of 1, the recent one. So this one is like you are using the Gauss-Seidel method, but multiplying each and every term by W. Then if we take this one, the first equation here, then we make x1 the subject of the formula, going to get something like this. X1 is going to be e minus bx2 over a. Then if you multiply the whole of this by W according to the algorithm here, so we're going to have something like this. X1 is equals to, since we are given that W it's a 0.5 open bracket e minus b x1 x2 initial, we are given that we should take it at 0, and then all of this divided by a. So this times that is 0, and then therefore we're going to have x1 is equals to e over 2a. That's our final answer. And then don't forget to tabulate your results. So if you tabulate your results, you're going to have something like this. This is M0 1, since they said we should do one iteration, and then this is x2 all divided by this, and then for x1 0 and 0 for x2, then the initial we got E all divided by 2a. That's our initial answer. Then let's move on to the second one for the x2. So for x2 is equals to, you make x2 the subject of the formula from equation 2, f minus c x1 all divided by d, and then x2 is equals to f minus c x1 all divided by d, d multiplied by omega OW. S2 x2 is equals to, this is 0.5, then now f, remember that this x1 is 1, we're using the recent one, so f minus c x, it's what you calculated previously. So what we calculated here, our x is this, so our x, since we're using the recent one, is going to be E divided by 2a, all of it divided by d. So you are going to have something like this. It's going to be f minus ce over 2a all divided by 2a. That's our answer. So this answer is for x2, the first iteration. So I don't have enough space, but it belongs to this space here. So let's move on to the next question. Oh, so it's one of a question from the past papers. Then it says, working to 4 significant figures with rounding at each step, determine the best approximation to the smallest root of. So here we are given an equation in the form of quadratic form. It's ax squared plus bx plus c. So we can use the quadratic formula to calculate the roots, provided that you have to check some like you have to check whether the b squared is greater than 4ac. Then after checking that is why you can decide, now I can use the quadratic formula. So here from this one, since our b, we can start by saying, since b squared is equals to 11.01 squared, which is greater than to 4ac, which is equals to 4 times what is a is 1.002 multiplied by c 0.01265. Since b is greater than this, therefore when you calculate the root of since b squared is greater than 4ac, and then if b squared is greater than that, therefore we are going to use one of these equations. We're going to say for one of the root x1 is going to be minus 2c divided by b plus the square root of b squared minus 4ac. So this equation comes from this one, is x1 is equals to minus b plus the square root of b squared minus 4ac all divided by 2a. And then we rationalized the numerator. Then after rationalizing the numerator, then we got this. So it's what you have to do here. If you're not lazy, you can do that. You can rationalize and then arrive to this formula. Or sometimes if maybe you are writing the exam and then you forgot this formula, you can rationalize and then get this. So here, actually we are not done here. If you arrive to this, you have to conclude another statement. You have to conclude that if this is the case, therefore b squared square root of b minus 4ac is approximately b. So remember that I showed you that equation that were rationalized initially was b minus b plus the square root of b squared minus 4ac all divided by 2a. This was equals to x1. So here remember that we're assuming this statement here. So if we're assuming this one here, so therefore remember that when you subtract the two numbers that are approximately similar, therefore the huge error is going to arise. That's the reason this is rationalized. Why? Because these two numbers are approximately equal. So therefore that's why we rationalize to get the new one, this one here. So that's the reason we are rationalizing it. So this statement here, don't leave it, it's important. This statement here, it gives the view of why we rationalized the original equation to get this. So we are going to use this equation to calculate one of the root, which is x1, and then x1 is going to be equals to minus 2. Our c, we are given the value of c is 0.01265, and then all divided by b, it's 11.01, and then plus the square root of b squared, which is 11.01 squared minus 4a. Oh, sorry, I have to substitute the value of a. The value of a is 1.002, and then multiplied by the value of c, which is 0.01265. Then we'll get something like this. The answer of x1 is going to be minus 2 open bracket 0.01265 divided by 11.01 plus the square root of 11.01 squared minus 1.002, then times by 0.01265. Alright, so final answer is going to be minus 1.491 times 10 to the power minus 3. That's your final answer. Then for the x2 is going to be x2. Since x2 we are adding is like we're adding the two equal numbers, and then there's no error. Then x2 is equals to minus b minus the square root of b squared minus 4ac. So this one, since it's like you are adding two numbers that are equal, therefore there's nothing that you have to do with the rationalizing. Then x2 is going to be equals to, I don't have enough space to substitute the values of a and b and c, but our final answer is going to be 0.98 is 98, yeah. And then actually it's going to be 99, because we are told that you have to round each calculation to 4 significant figures. So therefore this is your final answer for x2. That's your final answer for x1. Then you are done with this question. Let's move on to the next question. So we have this one here. Consider the function f of x is equals to 1 over 2x squared plus e to the power minus x. Using Newton's method to find x closer to 0.5. So that's your x initial. X initial is equals to 0.5, which will make f of x optimal. The that is a maximum or a minimum. Iterate to convergence. So what you have to do here, you have to know this maximum, minimum, and then also the point of inflection. You have to know 3 things, because if none of them are specified, if they didn't tell you that point of approximation of x is a point of inflection, or is a maximum, or is a minimum, we are going to use this formula. Xn plus 1 is equals to xn minus f of x divided by f of x prime. We are using this formula if none of these are specified. Like if they didn't tell you it's a point of inflection or maximum or minimum, use this formula. But if you are told now, because you know that now we're dealing with approximation of x at the maximum and minimum, then the formula is going to change to this. Xn plus 1 is equals to xn minus the derivative of this divided by the second derivative. So it's what we are going to do here, since we are told that this is at the maximum and then also minimum. Then what you have to do, we have to find the derivative of this function. So since the function is f of x is equals to 1 over 2 x squared plus e to the power minus x. So if it's like that, to find the derivative of simple f of x is equals to the derivative of this is 2 times that times half, which is 1, is going to be x, plus the derivative of this, remember that this is the same as e to the power x multiplied by times minus 1. So it's the same as that. So remember that if it's the same as this, we say minus 1 times this, which is going to be minus this, and then times that. So we're using the chain rule actually. So it's minus 1 times 1 here, which is going to be minus 1 e x to the power minus 2. And then we say the integral of this inside, which is going to be times e to the power x. So this again will give you the previous one. It's going to be x minus, since because you have a 2, e to the power minus 2x times e to the power x. And then it's going to give you the previous one. X is equals to x minus e to the power minus x. It's what you're going to have. Just change the minus, the sign only. So this is your first derivative. So this is my derivative here. First derivative. Then the second derivative, we are going to do the same. F of x, first derivative is equals to x minus e to the power minus x. Then I want to find the second derivative now. The f second derivative is equals to the derivative of x is 1. And then the derivative of this is going to be, as I told you, is going to be minus 1 times minus 1, which is going to be plus e to the power x to the exponent minus 2 times e to the power x, using chain rule. So by using a chain rule, you got that, and then it's going to be 1 plus e to the power minus x again. So this is your second derivative. Then after finding the second derivative, it's where you can do what? You can go and then substitute your formula. So your formula is this. Your formula is this here, is this. So this is your formula. It's why you have to substitute and then calculate 1, x1, x2, x3, up until you see your results starting to converge. So when your results start to converge, it's where you stop. So let's do that. Our x1 is equals to x0 minus f of x0 that were given prime divided by f of x0 second prime. Then x1 is equals to what is our x prime? Our x prime is we're given as 0.5 minus the f of 0.5 prime divided by the f of second prime of 0.5. Then we're going to get x1 as 0.5663. Then we're going to do the same for the x2 using this value as your xn now. Your xn now is going to be this value here that you calculated now. And then you got your answer as this. And then for the x2 is going to be 0.5671. Then for the x3 is going to be 0.5671. But you have to show step by step. You don't have to write the answer only. Then after that, you can see that after calculating the x2 it repeats itself according to our rounding here, because we rounded to 4 digits. Then therefore, if you rounded 4 digits, you see that x2 it repeats itself. Therefore, that means the function converges at third iteration. And then you have to stop. Just do that iteration, and then you have to stop on the third iteration, because it's where the functions start to converge. Then let's move on to the next question. So we have this one now. Consider the system 3x1 minus x2 plus x3 is equals to 1. x1 plus 6, x2 plus 2, x3 is equals to 0. 4x1 plus 3x2 plus 7x3 is equals to 4. Use the LU decomposition to solve the given system of equations using Excel arithmetic. Do not use partial pivoting when applying the method. So since we want to calculate the solution of this linear system using the LU decomposition, so you have to know this, that LU is equals to a matrix A. So LU, that means it's a lower matrix multiplied by the upper matrix, is equals to the matrix A. And then also that a lower matrix multiplied by variable y is equals to the constant B. And then upper matrix multiplied by variable x is equals to variable y. So it's what we are going to use now to calculate the solution of this equation. So when using LU decomposition, we're going to use the forward and then the backward substitution. So let's start by calculating our upper matrix. So our lower matrix, let's set it to this. Since we have 3 equations, so that means we are going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's our lower matrix. Then the upper matrix, we just calculate using the we reduce the matrix to the upper matrix using the row operations. So let's write the augmented matrix from these equations actually first time. And then if we write the augmented matrix from this, so that means we're writing this system in the form of AX is equals to B. We're writing this system in the form of that. So our A is going to be the constant of this, is 3 minus 1, 1, then 1, 6, 2. And then for the last row, it's going to be 4, 3, 7. And then remember that this is augmented matrix. We have to write it in the form of AB is equals to X. And then 3 minus 1, 1. And then the solution is 1. Then this is 1, 6, 2. Then solution is 0. Then it's 4, 3, 7. The solution is 4. and then we equate this to the variable x, x1, x2, and then x3. So we have that now. So what you have to do, we have to take this matrix here. We have to take this matrix here inside and then calculate, reduce it to the lower matrix using the row operations. So we are going to extract it. Then it's going to be 3 minus 1, 1, 1, 6, 2, 4, 3, 7. So I have to reduce this two elements here to 0, and then also this one to 0. So therefore I'm going to have the upper matrix. So to reduce that, we use the row operations. I assume that you guys should know how to use them. So here, to reduce this one, I'm going to say row 2 will tend to row 2 minus, remember that I will take this one here, 1 divided by 3, this multiplied by row 1. I will use a row 1 to reduce row 3 and row 2 and row 3. That's what I'm going to use. So from this, therefore, that means this one here is going to be row 3 tends to row 3 minus 4 out of 3 row 1. So we're going to calculate that, and then therefore remember that these two are the multipliers. There's 1 over 3 is the multiplier, and then 4 over 3 is the multiplier. And then if these two are the multipliers, I'm going to write this as this. This is the same as row 2 minus, remember that there's going to be 0.3333 row 1. And then this is going to be row 3 minus row 3 minus 1.333 row 1. I'm rounding it to the 4 decimal places, because if it's in this way, it's irrational. Then you have to round it off to the 4 decimal places. Then it's going to be 0.333, then 1.333 R1. So therefore, we are going to our lower matrix and then update our values. Remember that here previously we had 0 and zeros. So remember, we are going to substitute this. We are going to replace this 0 here by the multiplier that we used to reduce this 1 here to 0. So since for row 2 we used 0.3333, then this 0 here is going to change to 0.3333. And then the second 0, since we used 1.3333, so it's going to change now to 1.333. Then after that, you are going to calculate your lower matrix, and then this is going to give you something like this. The new matrix, therefore, the new matrix is going to be like this. The first row doesn't change, stay the same, and then the second one changes, is going to be 0. So our new matrix is going to be 0 minus 1, 1, and then 6.333, 1.667, and then 0 also, 4.333, and then 5.667. Then after that, now we're doing the row operation for this last row, to reduce this to the second element of the last row to 0. Then to reduce the second element of the last row, therefore we are going to say this R3 will tend to R3 minus this one here, which is 4.333 divided by 6.333. you know how it's going to be. It's going to be like this one. It's going to be like this. R3 turns to R3 minus, so this divide by that, because I took this, then divide by that to get the multiplier. Then to get the multiplier, I will get 0.6842. Now I multiply it by the row 2, because I would use the row 2 to reduce row 3. So if I use row 2 to reduce row 3, then after doing that, I will get a new matrix. So the new one is going to be like this. The new one, the matrix that I will get is going to be like 3 minus 1, 1, 0. Then let's use another color. Then it's going to be 6.33, 1.667, and then here 0 still. And then here it's going to be 0. And then this is going to change to 4.526. So this is our our upper matrix. This is the upper. And then here, remember that I have to update this 0 now by the multiplier. So my multiplier is 0.6842. So here, therefore, I will write 0.6842. That's my multiplier. Then after writing the multiplier, that's why now I got the lower matrix, I got the upper matrix. So what I have to do, I have to use these equations here in order to find my y and then also my x. So this is the upper matrix, that's the lower matrix. Therefore, I'm going to raise this here, so I will get a space. So let's do this. We start by this one, this equation here, because we have a b, we have the lower matrix, we're left with y. And then I'm going to say from this equation, I will get this. The lower matrix, which is this one here, is going to be 1, 0, 0, and then 0.33, and then 1, then 0, 1.33, and then 0.68, and then 1. Then multiply by y1, y2, and then y3. And then this is equals to b. So our b given is 1, 0, and then 4. Then if it's like that, therefore we're going to calculate y1. So we're going to say this y1 you multiply by the coefficient, which is 1. Therefore 1 multiplied by y1 is equals to the solution, which is this. So it's going to 1 times y1 is equals to 1. Therefore y1 is equals to 1. Then we're going to calculate y2. So y2, now we got this y1, then y2, that means you are doing the very same thing. For y2 is this, you multiply it by it, multiply here, and then also y1 you are going to multiply it by its multiplier. And then after doing that, therefore you are going to get something like this: y1 multiplied by 0.333, because this stands for y1, and then plus 1 times y2 is equals to 0. Therefore remember that this y1 is 1, and then if you transpose this to the other side, you will get y2 is equals to minus 0.3333, and then that's your y2. Then for y3 you do the very same thing. You're going to say y1 multiplied by 1.333, then you add it by y2 multiplied by 0.6842, and then plus y3 times 1 is equals to 4, which is this 4 here. So if it's equals to 4, therefore this 2, remember that y2 is not 1, you have it, it's here. and then y1 is 1, and then y3, therefore your final answer for y3 is going to be equals to 2.895. That's your y3. And then after getting your y1, y2 up to y3, just write it down, record it down here so that you can calculate x now. You can calculate x, and then just write your y1 is equals to 1, y2 is equals to minus 0.3333, and then y3 is equals to 2.895. Then you can use this equation here to calculate the x. So I'm going to erase this here so I can get a space. So I'm going to use that equation, the second equation, which says the upper matrix multiplied by x variable is equals to the y variable. So now I have the lower matrix, which is this one here. So let me do this actually. And then here I will take this lower upper matrix and then just multiply it by x1, x2, and then x3, then is equals to y1, I have it, it's 1, y2, it's minus 0.333, and then y3 is 2.895. Then just calculate. Remember that to calculate y, you are using a forward substitution, and then to calculate x, we are using the backward. So it's what we're going to use now. We start by calculating x3. That's why we're saying it's a backward. x3, x2, x1. Then for the forward, we start by y1, y2, y3. And then our x3, remember that is this here. x3, the x3 is this one here. And then the x3, we have a multiplier which is a 4.526. Then we're going to say x3, we multiply it by 4.526 is equals to 2.895. Then our x3 is going to be x3, when you punch on a calculator, we're going to get something like 1. Our x3 is going to be 0.6396. Then you do the very same process for x2. So for x2, you come here, the x2 multiplier is going to be this number here at the middle, and then for the x3 is going to be this one. And then when you do the same, you're going to get your x2 as equals to x2 minus 0.2210, and then your x1 is equals to 0.04647. That's your x1. Therefore you are done. So let's do this, the last question. So the last question says, is a question 2. Consider the system below, which can be formulated as ax is equals to b. 3x1 plus 6x2 plus 1, x3 is equals to minus 1. Then x2, x1, x2, x3 is equals to that. This also is equals to that. And then let's check the question. Is the matrix A diagonally dominant? Justify your answer mathematically and rearrange the rows of matrix A to obtain the diagonal dominant matrix. So don't go far. if you want to check whether the matrix is a diagonal dominant or not, just check this. Do you see this x1 here? Check the coefficient of it. So if the coefficient of a x1 is greater than the sum of the absolute value of the other elements, actually to check this is just absolute value of the first element, which is I must be greater than the sum of all other elements, which j is equals to 1 for j is not equals to I, and then the absolute value of a of I j. So if you find that the first element, the coefficient of the first variable, which is x1, or the first element of a matrix, the absolute value of that element is greater than the sum of absolute value of the other elements, therefore you will say that the matrix is diagonal dominant. So for this one, it's not, because this 3 is not greater than the sum of absolute value of 6 and 1. This 3 is not greater than, so we use this sign, is not greater than the absolute value of 3 is not greater than the absolute value of 6 plus the absolute value of 1. It's not greater than that. So if it's not, you have to rearrange this matrix like the matrix A to a diagonal dominant matrix. So to rearrange that, just write the matrix A first. So matrix A is equals to, remember that we are taking the coefficients only. It's going to be 3, then 6, 1, and then 1, 1, 3, and then 5, 2, 2. So here we are looking for the first time. You have to look for the greatest element in the first column. So the greatest element is 5. So if the greatest element is 5, therefore 3 is going to interchange with 5. Look for the greatest element in the first column. So the greatest element is 5. So therefore the first element is going to interchange with that element. So when they interchange, actually the whole row will interchange with this whole row here. And then to do that, therefore you say row 1 will interchange with row 3. Then let's say our A1 is going to be 5, 2, 2, 1, 1, 3, and then 3, 6, 1. And then you look now if you are done with the first one, because for the first time we were looking for the greatest element in the first row, then move to the second row. No, the second column, sorry. Then the second column, look from the second element to the last one, which is this 2 here. And then now we're comparing these two. So to compare the two, look the greatest element between these two. So the greatest element is the last one, is the 6. So therefore row 2 is going to interchange with row 3. And then therefore our final A is going to be 5, 2, 2, and then 3, 6, 1, and then 1, 1, 3. And then now you are done. So just look at it again and then check whether it satisfies this. So if it does, then you're done. Because if you can check, the absolute value of the first element, which is 5, is the greatest of the sum of the other elements, which are 2 and then 2. So 2 plus 2, so you can confirm this by saying the absolute value of 5 is greater than the absolute value of 2 plus the absolute value of 2, which is true. And then come to this, the second one, the absolute value of 6 is greater than the absolute value of 3 plus the absolute value of 1. And then for the last one, absolute value of 3 is greater than the absolute value of 1 plus the absolute value of 1. Then you are done. Oh, thanks for watching, guys. See you next time. Please, if you like these videos and then you want to watch more videos next time when I post the videos, please subscribe.